Greetings, Mr. Sutton here with the IM3 Honors 4-4 Part 2 homework solutions on quadratic systems. To find the point of intersection for this system, I'm going to replace the y over here with this x plus 3, because x plus 3 equals y over in this first equation. So writing x plus 3 equals 4x minus x squared, that'll let me get started on solving for x. So let me see here. I'm going to get everything on one side because I've got these linear x terms, so I know I can't just solve this by square rooting. So let me add the x squared over to the left side, and I'll call that 1x squared. And then we've already got an x over there. I'm going to subtract the 4x. That gives me a negative 3x over on the left side. And then we already have a 3 over there, and all this is going to equal 0 now. Now, we have a 1 for the a value, so I might be able to factor this. Let me see. Are there things that multiply to 3 and add up to negative 3? Well, the only possibilities for 3 are 1 and 3 for factors, and that's not going to add up to 3 or negative 3, even if they're both negative. So we're going to have to use quadratic formula. That's negative b plus or minus square root of b squared minus 4ac all over 2a. There it is. So plugging things in here, we have negative b value. The b value is this x coefficient of negative 3. So I'm going to write negative 3 for that. Plus or minus square root of negative 3 squared minus 4 times the a value 1 times the c value positive 3. All of that over 2 times my a value of 1. Simplifying things a little bit here, I've got a 3 over there. And then, let's see here, plus or minus square root of, this is 9 in here when I square negative 3. And then, let's see, 4 times 1 times 3, that's going to be minus 12 right there, all over 2. Well, this is negative 3 inside the square root. And all we can really do there is take out an I. Not much more simplifying to do. Unfortunately, this is not a legitimate x value. We're looking for an actual point of intersection on the x and y axis, and imaginary numbers are not on the real x and y axis. So this one actually ends up having no solution. For this one, finding the points of intersection, I'm going to use the substitution method here because we've got y isolated in each of these equations. So since 6x squared minus 8 equals y in this equation, I can replace the y in the second equation with 6x squared minus 8. And now I have a single equation with only one type of variable, just x's. Now, there's more good news. I notice there are no linear x terms. There's no x to the first power. There's only squared x's and constants. That means if I can isolate x squared, then I can solve this thing by square rooting. So let me try that out. Let me get all the x squareds on the left and all the constants on the right. So on the left, I've got 6x squared minus this 4x squared that I'm moving over there. That'll be a 2x squared. And then for the constants, adding 8 over here, we've got 64 plus 8, which is 72. To isolate x squared, I have to divide by 2. So we have x squared equals 36. And then I have to square root both sides now to get x. But now it's an equation that we're square rooting, so that means we have to have a plus or minus root when we do this. So this is going to be x equals plus or minus 6. And I'm not quite out of the woods yet. I have to plug positive 6 and negative 6 into one of these equations to get a y value to go with it. Let me plug positive 6 in first, and I'll use this first equation. Doesn't really matter which of these you use, but I would rather subtract 8 than add 64 if I can help it. So we've got 6 times 6 squared minus 8. Well, 6 squared, that's 36, times another 6 is going to be 216. 216 minus 8 is 208. And you could have done it on the calculator, but I was just able to pull that one off in my head. So that, anyway, gives us the point 6, 208. Now to plug negative 6 in, and I'll use this same equation up here. So we've got 6 times negative 6 squared minus 8. And we're really going to get the same thing, right? Because if you square 6 or negative 6, you still get positive 36 out of both of those situations. So we again have 6 times 36, which is still 216. 216 minus 8 is still 208. So this is going to give us the point negative 6, 208. For this problem, I'm trying to find out where these functions intersect, if anywhere. So let me start by replacing this y over here with the 3x minus 5 that equals this y in the other equation. Basically just substitution method. And let's get everything over to one side since I notice we have linear terms, so there's no other way to do it. Got to either factor or to use quadratic formula. So this 5x squared can stay where it is. I'm going to move this negative 3x over to the right side, or actually it's a positive 3x, but I'm subtracting it when I move it over there. So negative 4x minus this 3x is negative 7x. And then I'm going to add the 5 over here to be with the 9. That's plus 14. This is not my idea of a good time if you're trying to factor this. So let's just go ahead and use quadratic formula and hope for the best. So that's negative b plus or minus square root of b squared minus 4ac all over 2a. And now plugging in everything, we've got negative 7, that's my b value, plus or minus the square root of negative 7, the b value again, squared, minus 4 times the a value 5, times the c value 14, all of that over 2 times that a value of 5. Simplifying this a little bit, we've got 7 plus or minus square root of, this will be 49, and this is, let's see here, 20 times 14 is 280, so minus 280, all over 10. And inside here, 49 minus 280, that's going to be negative 231. And I can take out an I to simplify that a little bit. I don't think I can really simplify it anymore, but it doesn't matter because if you have an imaginary number, well, you're trying to find a point of intersection, so the x value can't be an imaginary number. That just means that there's actually no solution, that in fact these functions do not intersect at all. So no solution. For this problem, I'm going to take the x squared plus 7x that equals y over here and substitute it for this y in the second equation. Since I've got linear terms here, to solve for x, I'm actually going to have to get everything on one side, and maybe I can factor it. We'll find out. So let me keep the 2x squared over there, and let me subtract x squared over to the right side. 2x squared minus x squared is 1x squared, and then 10x minus the 7x that I'm moving over there, that's plus 3x. Negative 40 is still staying where it is. I think I can factor this. We need factors of negative 40 that add up to 3. So 1 and 40 doesn't work, neither does 2 and 20 or 4 and 10. 5 and 8, though, if I have negative 5 and positive 8, that adds up to 3. So let me split this up into x minus 5, x plus 8, which gives me the x value answers of 5 and negative 8. But now I need to plug each of these x values back into one of these equations to find y. I'm going to use the first equation. It's just got less going on. So plugging 5 into that first equation, we can write y equals 5 squared plus 7 times 5. Well, 5 squared is 25. 7 times 5 is 35. 25 plus 35 is 60. So that gives me the point 5 comma 60. Now for my other answer, I'm plugging negative 8 in, and I'll do it in this one here as well. So we have negative 8 squared plus 7 times negative 8. That's 64 minus 56. That just gives us positive 8. So then that gives me the answer negative 8 comma positive 8. It's kind of an interesting looking answer, and that's it.